Okay, welcome to Computer Vision Unlocked. What we have found here at Rendered AI is that there are just so many tools coming out in the use of artificial intelligence and the generation of synthetic data that it's almost impossible to navigate all of them. And so rather than try to share kind of tutorial information with you guys, what we actually thought would be interesting and useful is to hear from the experts themselves about, what tools they've used, why they've used those tools, and just remember that when we're engineering, at the end of the day, these are engineers. These are people that are making these decisions, and sometimes it's nice to get to know them and hear what their thoughts are. So with that, I'd like to introduce one of our engineers, Dylan Harkness. Dylan, can you say hi?
Hey, I'm Dylan Harkness. I've been working at Rendered for going on 5 years now. And interestingly, it's actually my first professional position is I was straight out of my bachelor's for application development and started working at Rendered. And just, things have gone from there where just learning a whole lot of things and working on lots of different projects. And it's been great.
Yeah. Your title is software engineer, but actually,
Oh,
Dylan's a rock star, and so he's been awesome for us. So, Dylan, can you tell us a little bit about the problem that you were trying to solve as we get into the tool selection phase?
yeah, and so we'll be talking about one of our services, the Inpainting service, and what this tool was designed to do is to take images and remove objects of interest out of them. And in this situation, we're talking about like satellite imagery. Is we've done a lot of different projects with customers where they have satellite imagery of their own, and then they have objects they want to remove from them. In other projects, we've also provided our own images. And in either case, there's real objects that you don't want in the data that will cause your training to be sort of skewed, as there'll be like false positives and things like that. And so you want those removed. And
So, like, let's say
originally,
you have
yeah,
a construction site image, and you want to be able to detect different objects within a construction site, and you want to be able to go from one image to many. If you try to just put things into it, you get overlap, you get issues around where placement should happen, and you've got to deal with the fact that there are actual objects already in that image. But if you clean it up, now that becomes something that you can use over and over again.
exactly, is our usual workflow for our satellites sort of RGB situations is we'll take 2D images and overlay 3D synthetic objects on them. And as Nathan was pointing out, if you maintain the original objects in that 2D image, they'll persist between various iterations when you try to generate volumes of data. And so removing those is really important so you can get as much variation as possible.
And this process called compositing, I mean, it's common in synthetic data. It's a tool we use. It's a tool everybody in this field uses among many different ways to generate this type of imagery. But Dylan, talk to us a little bit now. So you've got this challenge. You've got to remove objects from a scene. What are our options? Like, how did it used to be done, and what were you trying to figure out as you started exploring tools?
Yeah, so this sort of application is one of our earliest ones that we've tackled. And initially, we had just gotten a few images by hand, as maybe our customers would provide like 5 to 10 images, a really small volume, and we would go in with like image editing software like Photoshop or GIMP and remove
Mhm.
those objects just by hand. And on the small volume of images, that's fine. Is an artist can do that in just like a few minutes per object. And frequently, we would look for images where there were a few objects to begin with, so we didn't have to do a lot of work on that, and that worked perfectly fine. But as we've gone along with this process, we would offer larger amounts of backgrounds to our customers as we engaged with them in the different projects. And this generally ended up being like 20 backgrounds. And that was manageable. But as things went on, the types of
Yeah.
backgrounds changed.
When
It's
it's 20,000 backgrounds, that becomes a problem.
yeah,
So,
definitely.
so, so what tools did you explore as alternatives?
Yeah. So as an alternative to doing it by hand, we started looking into in-painting tools that use different sorts of AI in painting. The tool that we landed on was called IOPaint currently. It was originally Llama Cleaner, and as its name implies, it uses a llama model. And so with that one, you could define areas just by hand using a brush tool in the application you could run locally. You could also provide it masks. And it also has an API. And so with that in mind, we were like, we could make an automated process out of this, make a script. And so that's what we did is for one of our projects, we were doing really dense urban backgrounds and it was getting pretty hard to handle. And so we made sure to buckle down and get this automated process. And so we made a script that runs the API for IOPaint and it removes objects based off of we use the ground truth information to get the
Hmm.
positions of those objects. And then that script would take several minutes, like 8 minutes for a background that has hundreds of objects in it, and it would remove those. And so that was basically our first attempt at trying one of the tools, and it worked really well. And we can talk a little bit more about where it's gone, but yeah, so
All right,
that's
so IO Paint and kind of drop right in worked really well, and then you were able to use those annotations for new object placement too, right?
Yeah, that's true. Is those ground truth labels, we could maintain that information that we use from the metadata to create what we call placement areas in these 2D images. And
Mhm.
then, so where, say, a truck was in an original image, we could then place a different object there or a truck in that position. And then, depending on the labels, they might have orientated bounding boxes. And if it does have that, you could even maintain the orientation of the object, say, a car on a road is you could just put a new object that's on the road and it looks like it was there to begin with.
And so we started with satellite imagery. Have you used this tool on any other types of imagery at this point?
Yeah, we have. We've tried it on oblique imagery. We've tried it on sort of drone sort of angle. And on both applications, it's been very quick to use and gets to results very fast. Is
Gets to
so
effective
long,
like training results with the synthetic data being successful.
yeah, is it doesn't take long to begin with, and then you can use that data very quickly to turn around into a synthetic data pipeline and generate data within several days for potential some of these projects.
I love it. So we're using AI to take the little information we have about the world and turn it into a lot more that we can use to train an even more powerful AI. That's awesome. Really exciting stuff, Dylan. I appreciate you jumping on to share that with us.
Yeah, definitely. Thank you for having me.
Take care.